Good day, folks. Welcome to Bright Mind Academy, where we bring brilliance to every lesson. In today's video, we're gonna look at Euclidean Geometry question 10. Now it says to us, in the diagram, PTA is a common tangent. PTA is a common tangent of smaller and larger circle at A. Very important that we have a tangent. So the first information that we have a what? A tangent. All right. The second one, AMB is a diameter to the circle with M. All right, we have a diameter. Sorry, we have a diameter. That the information that I'm highlighting here, we should have reasons that include these. All right, number three, AC and BC are chords of the larger circle, and MS is chord of smaller circle. All right, M is the center of the larger circle. M is the center. So all center theorems will apply. All center theorems will apply from theorem 1 to theorem 1, theorem 2, theorem 3, theorem 7, 9. I think it's 9. All right. Now it is also given that length of AM it is P units, AS it is P minus 1, and BS it is 6 minus BS it is 6 units. All right. All right. Now let's try to see. All right, if this is my common tangent, and now remember I said I'm going to use these things now. Common tangent, what do I know about common tangent? All right, the first theorem that we learned about the tangent, it is that a tangent and a chord, if I'm not mistaken, a tangent, this is a tangent. All right, this is a diameter, it's not a chord. Let me say a tangent. Let's look at the smaller circle, right? Can you please look at the smaller circle? A tangent and a chord. AM, we were told that it is a what? All right, it is a chord. AM, it is a chord. The tangent and a chord AM, the angle subtended by that a tangent and this chord will equal to the angle subtended by the same chord. Which chord? AM. Chord AM subtends an angle at S1. So the first property that you can see, it is this one, right? So we can collect our data and say angle A3, it is equal to angle, I haven't looked at the questions. Angle A3, it is equal to angle S1. All right? Tan chord. Let me do the reasoning here. Tan chord what? Tan chord theorem. All right? Now, also angle A1, it is equal to angle M1. All right? A1 is equal to angle M1. Angle A1, it is equal to angle M1 also with the same reasoning. All right, I'm moving on. Then another property is that if I have a tangent, now I'm looking at the bigger circle, a tangent and a radius. If A and B, if A and B, A here, MB is a diameter, it means AM, it is a what? A radius, and MB, it is a what? A radius. Remember what is a radius? A radius, it is half of a diameter. So remember the theorem says if this is a tangent and this is a radius, at the point of contact, the angle that it makes there, it is how much? It is 90 degrees. So I'm going to say angle A3 is equal to 90 degrees. Why am I saying that? Tangent, it is perpendicular to the radius. All right. Also on this side, A1 and 2. All right. Then I think I'm done with a tangent theorem there. Or the last one, it is that tangents from the common point. Let's say we have a tangent that's from T and like that, but it is a tangent. So that we only have two theorems under tangent. Let's look at the diameter. I'm done with the tangent. I'm looking at the diameter now. Here's a diameter. It is a diameter to a what? To a bigger circle. And we know that an angle subtended by a diameter, which is angle C in this case, it is equal to how much? It is equal to 90 degrees. So we know that angle C, why are we saying that? Angle in the semicircle. Let me write semicircle. Circle. Remember, angle in the semicircle, it is equal to 90. Angle subtended by a diameter. Anything about the diameter gain? Nothing. I come here, center. What about center? Theorem 1 has a center. It says now, line from the center. Let me look at the bigger circle. Ne? And I was told that, where is it? BC is a chord, ASC is also a chord. I was told that ASC, it is a chord here. ASC, it is a chord. So now if I have a chord and now I have a center, I know line from the center is perpendicular to the chord. Line from center is perpendicular to the chord. So it means now if line from the center is perpendicular to the chord, it means now angle S1, it is equal to angle S2, it is equal to 90 degrees. Why are we going to say that? Line from center is perpendicular to the chord. Perpendicular to chord. All right? Therefore, if this is perpendicular to chord, it means AS will now equal to SC. Because if this line is cut by, there's no cutted, is cut by a perpendicular line, it makes these two sides equal. So it means now I'm going to say AS, it is equal to SC. Why am I saying that? Line from center bisects the chord. All right, or I can also use line from the center is perpendicular to the chord. Therefore this leads to that. Then I think I'm done with center because I cannot see angle at center is twice angle at the circumference, and I cannot see or I have already used one if this is the center and this is the radius and it's perpendicular. All right, let's try to tackle the questions now. This should be fairly easy because I think we have collected enough data. Name giving reasons 3 angles equal to 90. The first one is this one. This one. Angle C, it is equal to 90. Why? Here it is. Angle C, it is equal to 90. Why? Angle in the semicircle. The first one. Alright? Let's write them down here formally. 10.2.1. Angle C, it is equal to 90. Why are we saying that? Angle in the semicircle. All right. Number 2, the second one. Now, any angle that is equal to C, maybe let's look at any angle that is equal to C. All right, we do not see here, right? Angle A3, all right, angle A3 is equal to 90. Why? Tan chord. You see what's the importance of analyzing these statements that you are given here? If you analyze this statement, important statement, you get your answers. We are told that angle A3 is equal to 90 degrees. Angle A3, it is equal to 90 degrees. Who is that? Angle A3, it is equal to 90 degrees. Let me write this neatly. It is equal to 90 degrees. What is my reason? My reason is that tangent is perpendicular to chord. Let me see an angle that is equal to A3. Yes, I have an angle that is equal to A3. This angle, S1, angle S1, it is equal to A3. So it means angle S1, Leon, it is equal to 90. You see, I'm going to say angle S1 it is equal to angle A3. But I know angle A3 it is equal to 90. Why am I saying that? Tan chord. Here tan perpendicular to radius. Sorry about that. Perpendicular to radius. Here is tan chord theorem. All right, 3 marks, 6 marks. 6 marks. How is it 6 marks? Statement and reason. Statement and reason. Statement and reason. Geometry, it is statement and reason. Now, 10.2.2, I'm asked to state why. Give a reason why MS it is. Remember, let's do this. This is 90. This is 90. This is 90. So the question says give a reason why MS is perpendicular, is parallel, no, rather not perpendicular, parallel to BC. MS, why is MS parallel to BC? Well, I can see if I do this, if I extend this forms a corresponding angle, right? And I know this angle should be equal to angle. Is that the case? Yes. Why? Because they are both equal to 90. So I'm going to say angle S1 is equal to angle C. Angle S1 it is equal to angle C equal to 90. I have proven that. Therefore, if they are both equal, whether they are equal to 90 or not, but if they are equal in this case, then that means therefore B what? B what? MS MS is parallel to B BC. But you should give a reason why. Why is that the reason? The reason is that, remember, these are corresponding angles, right? So you can say corresponding angles are equal. Or, someone might say converse corresponding angles. Converse means reverse. All right. So you can say corresponding angles are equal or converse corresponding angles. Now I'm done. 10.2.3. Write down the ratio of AS to SC. The ratio, let me remove this. Ratio of AS to SC. Now, AS it is equal to SC. This is the information that I have. AS it is equal to SC. Why? Why am I saying AS is equal to SC? Because line from the center is perpendicular to chord, or line from the center to midpoint chord. Because if this is equal to 90, therefore this is the midpoint then. So it is gonna be the ratio there. It means if this is 5, this is also 5. So the ratio of 5 is to 5 is 1 is to 1. Remember, ratio should be in its simplest form again. And you were told that AS it is equal to my AS it was P minus 1. It means this is also P minus 1. But P minus 1 is to P minus 1 is the same. So it is 1 is to 1. Alright? So the ratio here it is 1 is to 1. 10.2.1. The ratio is 1 is to 1. Why are we saying that? The reason is that line from center to midpoint. 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 Mid PT. Midpoint chord. Midpoint chord. Alright? Line from the center to midpoint chord. 10.2.3. Here. 10.2.4. 10.2.4 says to us, write down the length of MS, giving reasons. Length of MS. MS, where is MS? Alright, let me remove this. I know this is equal to that, then MS. MS. Now let's look at this triangle. Let's take a close look at this triangle. Now, can you see that I'm having more or less something like this? Hmm? And now I know this one it is equal to that one. But you know there is this theorem that you learned. Hmm? There is this theorem that you learned that says if these two lines are equal, therefore this line is equal to that line. And if that's the case, this line here, this line, it is half of this line here. You still remember midpoint theorem? Still remember midpoint theorem? It says now if these two angles are equal and these ones are also equal, now then what? Then it means this angle, this line, this length here, it is half. It is half that length. All right? Yes. So, but what is this length? What is BC? We know BC it is 6 units. So what is the length of MS? The length of MS is going to be 3 units. Reasons midpoint theorem. MS is going to be equal to 3 units because you do not know whether it is in centimeters or what. Reason you're going to say midpoint what theorem? Or just write it in full. Theorem. For 2 marks, statement and reason. Here also statement and reason. Here, yeah. 10.2.5, I think it is the last one. 10.2.5 says to us, calculate the value of P. The value of P. Why? How? All right, let me remove this. The information that I was given is that this, it is what? Let me remove this. Remember, this is 90. Ne? And this it was P minus 1. And AM was P. Let me just confirm. AM was P, AS was P minus 1, and MS, we just prove it is how much? It is 3. But do you all agree with me that this thing that I'm seeing here, if I look closely into this small triangle, this is a right angled triangle. This is a right angled triangle. And I know for right angled triangle, I can use what? Theorem of Pythagoras. I can use what? Theorem of Pythagoras. Now let's see. Let's see, 10.2.5. Theorem of Pythagoras says this is the longer side, right? P, this is P, this is 3, this is P minus 1, this is 90 degrees. So the angle that the angle opposite to the 90 degrees, it is our hypotenuse, it is the biggest one again. So we know according to Pythagoras theorem is that, let me write it here first so that you can see. It says P squared, it is equal to what? This side squared. P minus 1 squared plus what? 3 squared. This is not me, it is Pythagoras. This is not me, it is what? It is Pythagoras. So let's go down with this and plot it here. All right? This is what? Pythagoras theorem. Pythagoras. Pyth. All right? Now, let's solve this mathematically. All right? It's going to be p squared, it is equal to, you square the first term, it is p squared. First term multiplied by second term, it is negative p multiplied by 2, negative 2p. Then you square the last term, it is plus 1 plus 3 squared, it is what? It is 9. If I have p squared, let me see. When you take this p squared to the other side, it's going to be 0, right? Therefore, it's going to be 0, it is equal to negative 2p plus 10, right? Then when I take this 2p to the other side, it's going to be positive 2p. It is equal to what? 10. And remember, this is the distance. The distance should be positive. Then I divide by 2. I divide by 2. Therefore, I get P, it is equal to what? 5 what? 5 units. I'm done. P, it is what? 5 units. Done. Done, 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 done. 5 units. So yeah, that's all for us, from me actually, in today's video, folks. So thank you very much for being here with me and watching my video. So if you liked the video and understood the concept, please give it a thumbs up, and kindly subscribe to the channel if you haven't done so. If you see any mistakes maybe that I have done, maybe within the questions, please put them in the comment section and I will try to fix that. Thank you.